It's okay. So this topic, what happens in US, it was introduced sometimes back, but in India still we are not having this. And but I love to do mathematics in some other areas also. So some of us, we are trying to explore this area because, it may give a new direction to have something more meaningful. So, okay, I believe not all of you like topology. So I should say what is topology. Whatever we see, it has a topology. We are wearing some clothes, it has a topology. So what does it mean? Some designs, some pictures are there. So that picture satisfies some conditions, and that we say that, okay, it is having topology. So they write something. So what is the important property we consider in topology? It's like if you take a rubber sheet and you pull it, then it looks like different. But we say that, okay, geometry is different, but topology is same. We'll give some good pictures. So goal of topology is to study the objects, whatever we can see. Now you can say that, okay, we cannot see that many interesting objects. So what are the other objects? We cannot see interesting objects. It's like, because we can see in 3D, but what about other dimension? Other dimension we can see because we can do the calculation. We are mathematicians. Right? So if we do the calculation, we can have many other interesting objects in mind. So what is important things in topology, you need imagination mind. That means you should have thinking power, which we are having. But maybe sometimes we are not interested. But if you have imaginative mind, topology is the best subject to have to learn. Okay. Let us go back. So this is example what we have. This is like donut, which you can get in several places. And if you are from South India, they say like some medu vada kind of things name. So in breakfast, and it is a very popular. So what you are going to do, you will get like coffee cup. So these two objects, they look like different, but in topology we say that they are same. So up to continuous movement, there is no property we are not describing, basic properties. Okay, so if you have any question, you should stop me. So some other things, so what is this? It looks like solid ball, so if we put in a press it, so it will be like sphere kind of things. So this connection we already noticed, so this is like hollow pipe kind of things, this is like hanger. And okay, as I told you, to see the pictures in topology, we should have some good mind to think. Here we can see a pair of pens, and that is related to double torus. So that means we have two torus, they are connected at some point. And this T-shirt, it is related to triple torus. So whatever object we see, as I told you, it has some topology up to something. Chair, bench, it does not matter, but we can give the topology structure. Okay? So that was related to topology, but now what we are interested in real life, we have some places and we are connected, like our home and universities. So every day we are going, so that means we are having some edges. So these edges are there. Now we have little bit abstract mind. What we will take? We will take some nodes and we will decide that, okay, whether there is connection or not. So that gives graphs. So we can see, given some nodes, we can have plenty of different kind of graphs. Okay, so this is little bit introduction of the graph theory. this, in various forms it can be. Nowadays this image processing, it is very important. So what we do, like we collect, means like we stored in some places, and then we try to understand how the data looks like or what application it is. So this is the usual way to do whatever statistical method is there. So we take the raw data, then we try to keep it somewhere. Then what we do, like observation, right? So processing observation, then we have this analysis, and then we can get some information. So this is a pipeline for the data. This is in usual sense. So I took the pictures from this website. Okay. So next two slides contain several things. Most of the things I don't know. So this, because I left statistics after BSc. Okay, so this is like volume data, or how much big it is, and what are the structures it can be, how we can keep it. So structured data, semi-structures, open. So these are like all things, all the terminologies we know, like the social media post, emails, chat, messages. So all the terminologies we know. So these are like data types. So several, there might be many more. Okay. But how, so what is the usual methods and techniques? There are something we use in data mining, all these topics also I am not that much. I mean, I know a little bit, but not too much. But this one is like all of us, we know that we studied in BSc and MSc in some statistics course. Okay. So this time series test. Okay. So this part goes the usual way to analyze the data. Now, so these pictures we know. Right? So this was known shape for the long time back. This was by statistician. So what they did, they took the data points and they tried to do the regression line and try to compare. So he took this data set. So if we see the X value in the first three data sets, they are same. Y values are different. So here 8.9. For the fourth data set, the X value is different from the others. Okay. So if we see this picture, we may think that the statistical parameters will be different. However, we have surprising things. So if we take mean of X, so for each of them it is same. If we take variance, we know the definition. So this is exactly same, mean of Y. Up to 2 decimal places it is same. The variance is also same. Correlation between X and Y. Up to 3 decimal places they are the same for each data category. Okay? So we should be like surprised. The data set looks like different, but if we apply the classical method, we are getting same result. Then how to distinguish that data set? Okay. So that may do that, then we get this picture. So pictures may look like different. I mean, actually it is looking different data set. But how to capture the information? Now, having one single class of data set which gives the same kind of statistical information, from there somebody can produce as many different class of data set which looks different, but they give the same parameters, statistical parameters. Okay. So what to do? So it gives the idea, okay, we should have different concept. So what is that? Some abstraction, then what we should find next. So can we have something more advanced shape? So that shape was like regression line and some data point. And so can we have something little bit more advanced shape? Okay. can we have some other question also? So given this data point, whether we can have more information, whatever information we are getting, can we have more information from there? I just put the name neural data because from there we can have many networks. Okay? So our brain networks, it has, if we subdivide and how they are working, we will get million networks because we are neurons, right? Okay. So the question, I mean, if you want, you can try to make more questions also, but these are the basic questions which we have. Now to answer this, how we can answer it? So that means what we discussed in the beginning, that topology discussed about the properties of the shape. So if we want to have advanced shape, so that means we need to bring back some topological notions. Okay. So this is another way to get some graph. And as we notice that if we are having more nodes and more interactions between them, then we will get more complicated data. But this gives the graph, right? So in the previous case, what it was, it gives the graph. But we want to have whether the network has some shape. So can we have some more topological tools to answer those previous questions? So whether we can have some shape. Okay, now up to this, is it okay? What is our goal? Right? So we have some data set, and then we want to have some shape of the data. Okay. Why not going? So around 2000 or 2002, some people they started to answer these questions, and it has some components which are known as persistent homology and persistent module, persistent diagram, and they found that it will be much more useful than whatever result we had. And that subject is called topological data analysis. So roughly I will say what is the pipeline, then I will discuss it broadly. So where that collection of points will be meaningful if we consider these points in some metric space. So that means there are some activities between them. So that metric is important. So it does not matter, it is not always the case that it has to be the Euclidean metric, but some other metric also. So having that metric, we can have some properties which will give the graph structure. Okay. So this, having that graph, what we can have some algorithm to have filtration. Yes, the simplicial complexes, so another new terminology which I will introduce. So from that data set, we had graph. From that graph, we could have simplicial complexes. This is higher dimensional generalization of the graph. And from the simplicial complex, so if we have simplicial complex, we get a topological object. So corresponding to data, we get a simplicial complex, that is topological object. And now topological data analysis means we need to study that object topologically. Okay. Then we can build the homology. So this topological or geometric features, it does not need to be always homology or cohomology, but some other things also you can think about it. People nowadays, they are doing like topological complexity, persistent topological complexity. That is also another thing. I believe that, personally, I believe that will be the correct way to do the topological data analysis. This is one way, so there is some other ways also. But I choose this way because what we want to do, we want to do the computation. And how we can do the computation? We have to put that algorithm in a machine language, so that the machine will do the work. So the fourth stage is for that. So it has to put in a machine so that it will give the answer. So that means it is related to the machine learning problem. Okay. So here you can have this. So what machine learning models we should have so that we will get the information about the data. Okay. So I took these pipelines from this paper. So this is an interesting paper which gives a very brief survey about this data analysis. Is it okay? So we had 4 components. One is data set, from data set to how to get the graph structure, from graph structure meaning like with metric, from if we have having metric, then how to get the simplicial complex. I will introduce all of them again. And then if we are having simplicial complex, that means we are having a topological space. Now for the topological space, we can do whatever we want from the topological side. Right? But that will help the topologist. What about the applied people? So applied people will be happy if we can do machine learning. Right? Then you tell your coding that okay, I am doing this coding and this will be the fastest coding or like fastest algorithm. Applied people will be happy